First, look for a pattern in the data. The manatee data exhibit a clear pattern, a clear relationship between the variables. As boat registrations increase, the number of manatees killed increases as well. This is called a positive association. Now, this is clearly not positive for the manatees, but it is positive in a statistical sense. As one variable increases, so does the other. Sometimes data exhibit a negative association. In this kind of relationship, as one variable increases, the other decreases. Learning is a classic example of a negative association. Let's look at the relationship between, say, how long it takes you to make a pie and the number of times you make one. The amount of time it takes to make a pie is the response variable, and the number of times you make one is the explanatory variable. We find that as the number of times you make a pie increases, the amount of time it takes you to make one decreases. So we say the two variables exhibit a negative association. You'll notice another thing about the manatee data. Most of the points fall along a straight line. We call this, for obvious reasons, a linear pattern. Now, we can't expect all of the points to fall exactly on a straight line. Actual figures are rarely so cooperative. But we can call a pattern linear if the data points fall roughly along a line. Other patterns in data are also possible. This graph shows a curving relationship between two variables. It suggests that the variables increase together until one increases faster than the other. The important thing is to look for patterns in scatterplot data, because any strong pattern, whether linear or curved or something else, helps us interpret data in powerful ways. So the key is to be able to recognize a pattern when it exists. Now, what about those points that don't fit so well? Once you've described the overall pattern of a scatterplot, it's important to identify individual points like this one that clearly lie outside the overall pattern. These points are called outliers. An outlier has to be explained. Sometimes it's simply a mistake. You recorded the data incorrectly or made a mistake in drawing the plot. When it's correct, though, an outlier may point to something unusual that you want to know about. Suppose this is a plot of lake temperature readings in an active volcano region in Hawaii. This one is much hotter. It could mean that the sensor is broken, or it could indicate the volcano is about to blow. Investigating this outlier could profoundly affect the people who live in the surrounding towns.